All right, today I want to take a little bit of time and talk about let and variants of let in Emacs-lisp. A couple times ago I've showed you that a typical way of assigning a variable is with setQ. So let's do setQ, z is 1 and maybe y is 2. And now I can use these to add them, say y plus z. Now, an important point to remember when you use setQ is normally when I use it like this, z and y are now global variables. And so if I have a new window here and I look at the contents of y, it's been stored. And that's not always desirable. We don't always want variables hanging around in space or hanging around in our namespace. And so there is a whole set of tools in Emacs-lisp for temporarily defining variables in a scope so they don't exist outside. And the one that I use very often is let, and the syntax looks like this. So let's do a is equal to 1 and b is equal to 2. These are the so-called bindings, and this is going to bind the variable a to have a value of 1 and the variable b to have a value of 2. And then inside of this scope, inside the let statement, we can do a plus b. And then we'll close this. And now this is a little closure, if you like. I'm using it in a slightly different way, maybe. But a and b will execute and evaluate to 3. But if we look down here and try to look at the value of a, it says it's void, it's not defined. So a only exists inside this scope. And this is like in other languages like Python, you can define variables inside a function and they only exist in that function. So that's pretty helpful. And same with b. B is not going to be defined because it is only inside this little scope up here. So a lot of times we'll see something like this. We can even use this to redefine the values of z or y. So let's say, again, let's make z have a value of 4 in this case. And now we can look at plus y and z. And if I evaluate this, we get 6, maybe as expected. But let's look at what happens to the value of z. It hasn't changed in here because we only temporarily defined it inside this loop to have the value 4. So we're able to shadow the value of z temporarily without changing it. And that can be helpful if you want to change the behavior of functions by changing a variable in there, for example. All right, the next thing we want to look at is what happens when these bindings depend on each other. So if I go back to my a value, let's say a is going to be 1 again. But now let's say I want b to be 2 times a. And then we want to, let's just add them again so we have something to do. If we do that, we get an error that the variable is void a. So when we look at the normal let statement, then this a is invisible. It only evaluates these independently. So we have to look at a variant called let star. So if you put let star in here, now this line can use the value in here and we'll get the result that you expect. So there's 2 functions probably macros to remember, let and let star. And you use let when all of the lines are independent and let star when this line depends on this line. And you can always use let star. It's not like it's wrong to use it if they're not dependent on each other. It's just unnecessary. Okay, so those are the 2 main ways that I've used let, and there's whole books written about let over lambda and really fancy things that you could do where you could say capture the variable and do something interesting with it. It's a little more advanced than we should probably get into today, but we'll do it maybe another day. There's 2 more lets I want to talk about, and that is a clever way of doing something called destructuring or unpacking variables. So let's look at let a list first. So why don't we just look up let a list, and I'll make this a little bit bigger so you can see it. This is in this let a list.l, and it's a fancy syntax that we can use as our argument in a list, and it will bind all of the cars, the first element in each console, to a dot title, and this will have the value associated with it. So it's a lot easier to show you than it is to unpack that. So let's say we have an a list that's a.1 and another that's b.2. So since I have this as the argument for let a list, then down here we can say dot a and dot b, and this is going to evaluate now to 3. So it takes the a list here, and it's going to create these new variables dot a and dot b and allow you to use them. So that's a really handy way of accessing this data, other than what we might have done in a previous video of the cdr of the ASOC of A and the cdr of the ASOC of B, and then adding that. Here's a very short syntax. And maybe the last one that I'll talk about is sequence let. So seq let. Let's check out this one. This has somewhat dense arguments here. We have the sequence let, you give it some arguments, you give it a sequence, and then it will unpack all of the sequence into the args, and then you can use those in the body. So let's say I want to define two variables a and b that are defined by the list 1 and 2. What this will do is unpack 1 into a and 2 into b, and then we can just add those two things together. And that will unpack and give us the desired result 3. So this is really helpful if you're familiar with unpacking variables in Python, like a comma b comma c equals the output of some function that returns 3 things. This is more or less equal to that. There is one more kind of destructuring, unpacking macro called pcase that is done using patterns, but I find it pretty hard to follow most of the time and rarely end up using it. So I think it should probably be its own dedicated video one day on all the nuances of it. It has a, let's check it out, pcase-let. So here we have pcase, let, bindings, and the rest of the body. Like let, but supports destructuring bindings using pcase patterns. That's not very helpful. Maybe we click on this. Here you can see some, let's see, how does it look? It's kind of small. There's all these different ways of defining a pattern, including predicates and strings and integers. Maybe for fun we'll try it just to see how it looks. Pcase let, and then I think we have to do this, comma a, comma b, 1, 2, plus a, b. Okay, so that is how it works. So this is a pcase pattern, and it's a back-quoted list here, and then the comma means that we're going to put the first value here into A and the second into B, and this is pretty much the limit of my pcase pattern abilities without spending a lot of time on Stack Overflow and reading these documents over here. In any case, let's just make sure that we have A is not defined anywhere, and B is not defined anywhere. So even though we were using A and B in all of these examples, they are never defined in the global space. They are only temporarily defined inside these scopes, which is, it's just very helpful to not have to worry about leakage of your variables. So that's it. I just thought today we would talk about different ways of using let star, You'll see that a lot in the scimax code where we temporarily define variables that don't need to be defined elsewhere. And you can even set Q in here. So let's do one more example. So let's say we just are going to let these be like this. Then I can say set Q A to be 1, B to be 2. And now this is only setting the local copy. And so no surprise, this should give us 3. And it could be a surprise that A is not defined even though we use set Q. But the critical point is that when we use set Q here, we're using it on this locally defined A that only exists in the scope. And so you can set Q inside here without affecting an outside value. And that is also true for the YZ value. So sometimes if you don't know what A and B are going to be in advance, but you know you're going to use set Q to define them, you could wrap them in a let statement so that you don't pollute your namespace. All right, that's it for today. Thanks for coming, and I will see you next time.